Hey guys, we are going to dig into the unit circle a little bit today. I just made it full width so you can see my writing a little bit better, but I'm actually going to zoom out here for a second. So you should have this copy of the unit circle. Originally, we're going to do one blank and look at it that way, but I think this is just going to be easier for us to be able to look at it with everything written in and then kind of pick apart some of the important pieces. So there's a couple different things I'm going to highlight and whatnot. On the back side, you have this blank chart. And we could start filling in some information about radians, right? We know that there's a connection between degrees and radians related to 180s. So like a 30-degree angle, 30 is 1/6 of 180. And so our answer is pi over 6. 45, that's breaking it into fourths. 60 would be breaking it into thirds. And 90 would be cutting it in half. And eventually we'll get this back page filled in, but for now let's just focus on the circle. So I'm gonna blow it up big again. So this is our unit circle, and the reason it's called that, is because the radius of the circle is 1. So what that means is, for example, from the center to any point, a radius of 1 means the length to the outside of the circle, in this case to 1, 0, that r is 1. And so you'll notice on all of the 90 degrees, the ones that would be on the axes, right? All of those, the ordered pair is 1. And what's cool is we can figure out the ordered pair just based on what axis we're on. So for example, if we go up 1, to 90 and get to that spot on the circle, that's why our ordered pair is 0, 1. If we go left, we can see -1, 0, and then bottom 0, -1. That's honestly why it's called the unit circle, just the word unit meaning the word 1. A quick note for you is all of these ordered pairs are xy, but they also represent cosine of an angle, sine of an angle. I like to think in terms of alphabetical order. X comes before Y in the alphabet, or in the dictionary or whatever. Cosine comes before sine. So every ordered pair has that as sort of its pattern. Now the other key thing here is if we want to know a little bit about tangent, we're going to take the Y value divided by the X value. And that'll tell us tangent of our theta. And that's a little bit trickier, but you'll start to see how it all kind of fits together. It just gets weird when you have to rationalize the denominator, but I promise we won't get too intense with that. But everything's connected. Now, obviously, if we wanted to do secant, we would just do the reciprocal of x. And if we wanted to do cosecant, we do the reciprocal of sine, right? We kind of know what those are. There's some general information. Now, I want to talk a little bit about some of the patterns that we're going to see here. So I'm going to start just really simply. I'm going to use my orange. If you have different colors and want to make yours different, that's totally fine. If you don't, maybe at least get out a highlighter and I'll tell you which one to highlight. I'll use a highlighter tool when it's time because I want to be able to show you a couple things. So the first thing we're looking at here is we're looking at the 4 I don't want to call them corners because circles don't have corners, but each of these sort of 90-degree spots. They're the ones that live on the axis, and they're all multiples of 90. And we'll notice that when we look at those, so like 90 degrees, it's halfway to 180, so it's pi over 2. What I love about this is the other one that's pi over 2. Well, 3 pi over 2 because we've done 3 of those 90-degree chunks. They're sort of similar, right? It's just all about what's positive and what's negative. And we'll talk about that here as we go. The 180s are kind of the same with pi and 2 pi and 3 pi and 4 pi and 5 pi and 6 pi and 7 pi, right? The multiples follow the same pattern, and it's all tied to reference angles. Okay. I told you I would let you know when to highlight. Here's what I'm going to highlight. I am going to do, let's see, I'm going to do my pi over 6 chunk. So I'm going to highlight that. So if you've got a highlighter, you don't have to do all the colors I'm going to do, but it would be kind of cool to look at this. So this is a 30-degree angle, which is great. More importantly, it's a pi over 6 angle. And for pi over 6, we have this ordered pair. Root 3 over 2, comma 1/2. So just to remind you that cosine of 30 or cosine of pi over 6 is root 3 over 2, because that's the x-coordinate. Sine of 30 or sine of pi over 6 would be 1/2. That's what this ordered pair is telling us. This is the cosine, this is the sine. Here's what I think is super cool. There's other angles here that have a denominator of 6. There's 5 pi over 6, which corresponds to 150. That's this angle right here. And what's super cool is the ordered pair looks the same. We've just introduced a negative in the x spot, which makes sense. We've gone left on the axis, going left is negative, right? If you want to add that, you could add, like, this is where x is negative, this is where x is positive, this is where y is positive. Oops, there we go. This is where y is negative as we go down. Not sure that you need that reminder, but sometimes it helps. Anyway, back to what I think is really super cool. So this pi over 6 for 30 degrees with cosine root 3 over 2 sine 1/2. 5 pi over 6 has similar vibes, right? It's got the negative root 3 over 2 because we've gone left. We're still above, so we're at 1/2. Now, there's another one, and it's 7 pi over 6, or 210. And it's got the same ordered pair, root 3 over 2, negative 1/2. And then same with 11 pi over 6. All 4 of those, all of the ones that are over 6, all have the same ordered pair. It's just a matter of what's positive and what's negative. Okay, so that's pretty cool. And now I'm going to show you it for the rest of them. I'm not going to highlight anymore, so if you don't want to highlight anymore, that's fine. Let's look at our pi over 4s. So 45 degrees is 1/4 of the way. Oops, that was a terrible line. I'm going to redo that because I'm like that. You guys know that by now. So I'm going to look at this line, or this angle. And for this particular angle, it's root 2 over 2 root 2 over 2. So that would mean that cosine of 45 is root 2 over 2, sine pi over 4 is root 2 over 2. The 3 pi over 4 here in this other quadrant has the exact same value. Just a matter of what's positive and what's negative. Zooming down here. 225 pi over 5 pi over 4. Similar ordered pairs as what we saw up here, root 2 over 2. Just a matter of in a different quadrant, so the negatives change. And I promise I will show you what's positive and what's negative in each spot. So the 7 pi over 4 and 315 down here. Right, same thing. X just so happens to be positive because we're on the positive side for X. Y happens to be negative because we've gone down below. But the ordered pair, the actual numbers, are the same. I just think that's so cool. Very last fraction for radians that we care about is pi over 3. Pi over 3 is 60 degrees. You'll notice that this right here, this particular ordered pair, is very similar to the 30-degree one. And remember, that's just because they are complementary angles, 60 and 30. That's why those two are so connected here. We could look at all of our pi over 3s here. And we'd see the same ordered pair. So really, if you knew the first quadrant, you know all the quadrants. Whoa, that line got questionable there. Let's try that again. But they all sort of fit together, right? All the over 3s have similar ordered pairs, right? But really, if we had to lock it down, the most important thing that we've seen here is this. X is cosine, y is sine. Speaking of sines and cosines and positives and negatives, let's take a quick look at that. Okay, so we've got our quadrants, right? This first spot, this is quadrant 1. And in here, everything is positive. So not super exciting. Sometimes you'll see that written as all. In quadrant 2, some things are positive, some things are negative. We've moved left of the, essentially on the number line or on the graph, and left represents negative in terms of x. X is cosine, so cosine is negative. Tangent is also negative. But because we're still above, we've still stayed up, sine is positive. Down here, because, maybe I should add this in here, because all the ordered pairs here are negative for x, positive for y. That's what happens in Q2. In the third quadrant, tangent's positive, but because of where we're living, sine and cosine are both negative, right? All the ordered pairs here are negative, negative. It just so happens that when you divide two negatives, that's why tangent turns back positive. And in quadrant 4, we are looking at ordered pairs where x is positive, but y is negative. So in terms of our trig stuff, sine, whoops, that's not what I want. Hopefully you didn't write that down. Cosine is positive because x is positive, but sine is negative. And since cosine and sine are different signs, tangent's also negative. Maybe we want to add that down here at the bottom. Actually, we've got a good little housekeeping spot at the top. Let's put it at the top. If cosine and sine are different, in other words, one positive, one negative, that doesn't say one it, that's supposed to say 1 plus. So I'll make that less of a T and more of a plus. One positive, one negative. Tangent is negative. So a lot of information living in our lovely, lovely unit circle. Here's how we would use this. Okay, here's how we use this. And you can write this down if you want to, but if you don't want to, that's fine. Let's say all of a sudden I started filling in the back, and I was like, sine of 30. So I'd be like, okay, I want to know the sine of 30. And I'd be like, unit circle, where you at? Here's 30 degrees. Sine of 30 is 1/2, because according to the ordered pair, the y, whoops, that's not ideal. The y coordinate here, or the y part of the coordinate, is 1/2. If I wanted to know cosine of 30, I'd go back to that ordered pair and I'd check the x coordinate. Let's do another one for fun. Let's say I wanted to know um, 330, and I want to know the sine. So I'm not actually going to, go like this. Still in the sine column, I just don't want to draw it super long. So I'd come up here and I'd be like, ooh, 330, here's where you're at. And I'd look at, okay, sine. Sine is the y coordinate. Here's the y for this one. So my sine of 330 must be negative 1/2. Right? That's how I read this. So as you get a worksheet here in a little bit that you can work with someone to tackle, that's what you're looking for is what's the x-coordinate, what's the y-coordinate, or do I need to divide them, or do I need to take the reciprocal? So you can do this. I believe in you.